Welcome back. We're still training on pH and pOH, and let's see what they have for us here. Here they give us the hydroxide concentration of something, and they want its H3O. Two ways you could do this. One, you could take this number, and which is the hydroxide concentration. You could negative log that. You could do negative log OH, and that would give you the pOH. Then 14 minus the pOH would give you the pH. And then 10 to the minus pH would give you the H3O. That would absolutely work. Another way you could do this, you remember we said quite a while ago that anytime you have OH and H3O in a solution, their equilibrium constant is 1 times 10 to the minus 14, the ionization product for water. That means anytime you're in water, your H3O concentration times your OH concentration should come out to 1 times 10 to the minus 14, which means H3O, if you take both sides of this and divide by OH, you get H3O is 1 times 10 to the minus 14 divided by the OH concentration, in this case 1.59 times 10 to the minus 11. 1 times 10 to the minus 14 divided by 1.59 times 10 to the minus 11 comes out to 6.29 times 10 to the minus 4. That should be it. If this makes sense to you, wonderful. It's a good move to know. If it didn't feel right to you, or if you prefer this way, by all means try it out, and you should get 6.29 times 10 to the minus 4 anyway. I won't do this every time, but if there's two ways to solve something, it's good to know one, it's very good to know both. Okay, what is the H3O in a solution with a pH of da da da? There's one formula for this. The H3O concentration of something is 10 to the minus pH. So for this, 10 to the power of minus 3.68. No human can do that, I don't think, but 10 to the power of 3.68 negative. The calculator does it with no trouble, and I get 2.0893 times 10 to the minus 4. And that's moles per liter. How many sig digs should our answer have? Don't say 3. In a pH, remember, this 3 is not significant. Only these two digits are significant. So we've got 2 sig digs. Our answer should have 2 sig digs, which means actually this should be rounded to 2.1 times 10 to the minus 4. That's all we're allowed. Moles per liter H3O. Okay, pOH of 10.5. Two ways we could solve. One way we could solve this is we could do 10 to the minus pOH and get the hydroxide concentration, and then do this thing and get the H3O. But what I feel will be easier is we can get the pH by doing 14 minus 10.5. And now that we have the pH, H3O is 10 to the minus. The concentration of either thing is 10 to the minus the corresponding P number. So in this case, 10 to the minus 3.5 is what we want. 10yx 3.5 negative. I get 3.16 times 10 to the minus, not a lot of variety in these questions. We keep getting 4. It's a concentration, so it should have units. What else do they have for us? pH of 13, calculate hydronium and hydroxide. Well, hydronium's easy enough. H3O is 10 to the minus pH, so 10 to the minus 13. which if you put that in the calculator, it's going to pretty much echo it back to you. It'll say 1 times 10 to the minus 13, and that's moles per liter. In other words, 10 to the minus 13 is already scientific, other than it should have a 1 in front of it. Now, we could do that H3O times OH equals 10 to the minus 14 thing from here to get the OH, or the other way we could do it, which I find a little more comfortable. If the pH is 13, the POH is 14 minus 13, which is 1. And now we can use the 10 to the power formula again. Hydroxide will be 10 to the minus 1, which you could write as 1 times 10 to the minus 1 moles per liter, or as 0.1. For SIGDIGs, this had 2, so here I should have 1.0, apologies for that, and that should be 0.10, or that should be 1.0. Sorry, bit scrunched. But anyway, 2 significant digits, whatever format you choose to go with. Very strong acid solution has a pH of -2, and they want hydronium, which is this. Okay, well, a formula tells us what to do here, except there's a little bit of a trap in this one. The formula says you do 10 to the minus pH, and a lot of people are going to write this. Why is that wrong? There should be 2 negative signs is the problem. The formula says do 10 to the minus and then put the pH. The pH is -2. And then those negatives cancel and you get 10 to the normal 2, which is actually 100. If you had an acid solution with a pH of 2, it would mean the concentration was 100 moles per liter, which is outrageously thick. I don't know if this is possible, and if it was, it wouldn't be a solution. It would be like a glob of acid with a little bit of water in it instead of the usual, which is water with some acid in it. This is an overwhelming amount of acid, but that's what the formula gives us, and if you calculated it like this, you're right. The point of this question is be careful with your negatives. The formula has a negative, and sometimes your pH will as well. Don't mishandle those and cost yourself a point. And finally, oyster stew has a very slightly acidic pH, like a lot of food. They want its OH concentration. Well, this is about acid and this is about base, so we need to make a switch. We can find the POH of this stew because the POH is 14 minus 651, which is 749. Now that we know that, the hydroxide concentration is, remember it? 10 to the minus POH, which means 10 to the minus 7.49. 10 power 7.49 negative. My calculator kind of runs out of space on this one and gives me 3.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 10 to the negative 8 moles per liter. Is that enough SIGDIGs? It actually is, because on this pH the 6 isn't significant, only these digits are. So our answer should only have 2 SIGDIGs, so my calculator just barely gave me enough. If that hadn't been enough, I don't know, you'd have to get a better calculator or start up a spreadsheet where you can get more decimal places, something like that. But anyway, that's these are kind of daily skills that you use when you're handling pHs and acids and bases. I hope that's getting comfortable. If it isn't, as usual, please get a hold of us and we will be happy to assist. See you next time.